Hi guys, welcome to another episode of my YouTube lesson. In today's video, we are going to be looking at the another question that we have here is under the isotopes. And in our last class, we discussed that the isotope is the existence of two or more atoms of the same element. They were going to have the same atomic number but different mass number. So the question we have here is this: the relative atomic mass of boron is 10.2. That's their relative atomic mass. If the element occurs naturally in two isotopes with isotopic form 10, 5, boron. This is B is representing the symbol for boron, and the second one is 11 and 5. So, what are their genome abundance? You say we should find the abundance, and in our last class, I explained that the abundance is always mentioned in percentage. This is the first mass one. The mass one is 10, and the mass two is 11. The mass two is 11. So the first thing, let's write our given data. What we are given the relative atomic mass of the two to be 10.2, and let's say let the abundance one of 10 be 10.5 be to be equal to abundance 1. Let the first one to be abundance 1, and then also let the abundance 2 of 11 and 5 to be equal to abundance 2. And then don't forget our M1 from the question. Also, our M1 is 10 and M2 is 11 from the question. So now we are not given any percentage for the two. Abundance is measured in percentage. So we can just, let's say that anytime we want to solve for the abundance 1, we will now say let abundance 2 now to be equal to 1 minus abundance 1. And anytime you want to solve for the abundance 2 also, we say that let abundance 1 to be equal to 1 minus abundance 2. So from the formula I gave you last class, we said that the relative atomic mass will be equal M1 abundance 1 plus M2 abundance 2. So it depends on the number of abundance you are given. I mean, the number of elements you are given will determine the number of mass we are going to store. It can be 3, it can be 4, it can be 5. So, but what's common mostly is 3. But this question we only have 2. So the relative atomic mass is 10.2. It be equal to 10 abundance 1 plus 11 in bracket abundance 1 minus abundance 2. The abundance 2, we say that abundance 2 be equal to 1 minus abundance 1. So for us to solve abundance 1, so it's going to be abundance 1. So now 10.2 will be equal to 10 abundance 1 plus, so we are going to open this bracket up. So we are going to have 11 minus 11 abundance 1. So at this point, you are going to collect the like time. So 10.2 minus 11, this one will come here. This plus, entire plus will come to this side. You change to minus to be equal to 10 abundance 1 minus 11 abundance 1. So this one will give us negative 0.8, and this one will give us 1 abundance. Negative 1 abundance. So negative, we cancel out negative. So we are going to be left with 0.8 to be equal to 1 abundance. So now abundance will be equal to 0.8. And we are not going to stop here. Our abundance is mentioned in percentage. So we now write, so abundance of 10, 5 boron will be equal to 0.8 multiplied by 100. This one over 1, this one over 1, because they are mentioned, abundance are only mentioned in percentage. So 10, 5 boron will be equal to 80% for the abundance 1. So now our abundance 1 now will be equal 80%. So for the second one, we're going to have, let's divide it into 2 so that we will not have anything mixed up. So relative atomic mass will be equal to M1 abundance 1 plus M2 abundance 2. So we want to solve for the second one. So 10.2 will be equal to 10. So we are going to make this one also 1 minus abundance 2. We are going to write it, let abundance 1 to be equal to 1 minus abundance 2 plus M2. Our M2 is what? Our M2 is 11. Sorry, our M2 is 11 abundance 2. So here we are going to open the bracket up. 10 minus 10 abundance 2, we are going to multiply it plus 11 abundance 2. So when we get to this point, we are going to collect the like time again, the way we did when we are solving for abundance 1. We are going to collect the like times. So we are going to have 10.2 minus 10 to be equal negative 10 abundance 2 plus abundance 11 abundance 2. So this one is going to give us 0.2, and the other one is going to give us 1 abundance 2. So our abundance 2 now is going to be 0.2. Remember, we are not going to stop here because our abundance is always mentioned in percentage. So we now write again abundance of 11.5 boron will be equal 0.2 upon 1 multiplied by 100 upon 1 also. So we multiply it with 100. So the answer for this one is going to be 20% also. So abundance 2 now, it's now going to be 20%. So we can also confirm our answer. So now, when we get to this point now, so abundance 1 is going to be 80, the second one is going to be 20. So if you add it together, 18 and 20 is going to give us 100. So we can confirm our answer from our formula. Let's confirm it later whether we are right or not. So it's going to be M1 abundance 1 plus M2 abundance 2. Remember, the relative atomic mass is 10.2. Let's see whether it's going to be equal to 10.2 again. So this one, M1 is 10. We have gotten this one to be 80. And don't forget the percentage, we are going to divide it this time around, divided by 100 plus 11 multiplied by 2 upon 100 also. So we are going to divide by 100. So this one will give us 10.2 to be equal to 10 multiplied by 80 divided by 100. This one will give us 8. If we divide by 100, it's going to give us 8. And this one will give us 11 multiplied by 20 divided by 100. This one will give us 2.2. So if we add it together, so it's going to give us 10.2. This now is going to be equal to each other from the question, which is the 10.2, the relative abundance, relative atomic mass, which is 10.2. So come to the end of our today's class. So if you are new to my YouTube channel, please kindly help me to subscribe to my YouTube channel in order for you to know whether when I post another video based on this. So thank you.